All right. Thank you, Ghaida. All right. So one element in a compound and will produce one element in a compound as well. Now, whether this is going to replace the R and make a TS or not, it depends on the reactivity between the T and the R. We have that's why we have the activity series, which is listing the elements, about 10 or 15 elements. Every element can replace all the elements that is below listed below it in the activity series. And when it comes to the halogens, the activity or reactivity, it will go down as we go down the group, or will decrease as we go down the group. So that's why fluorine can replace all the other halogens. Chlorine can do the same thing, but if you react a bromine, if this is, for example, a bromine and that is a chlorine, then it cannot replace it. There will be no reaction. Okay, and the double replacement, it is where we have the positive ions are getting replaced. So when you say positive ions, this means that we have two ionic compounds. So these two ionic compounds, RS and TU, they exist like this. And this is very important for you to understand that, because this is what we will be doing today, simply because we will be looking at the reaction in aqueous solution. And that is what we mean by existing like that. Okay, existing like this, it is originally RS, but because this is an ionic compound in aqueous media, then it will be as R plus S minus. And that is the ionic form. I mean, I'm just giving you a little bit of introduction to section 3. And this one is the same. So the positive ions are the one that is getting replaced, and they will produce two ionic compounds. Now, these two ionic compounds in here, there are three possibilities, and the majority of them, that is the one which will form a precipitate. One of those is an ionic compound, but it is water insoluble. So it will form a precipitate, or whenever we have an acid-base reaction, that is also considered as a double replacement. When we have acid and base, they neutralize each other and they produce water and a salt. That's why we say that the second possibility is the formation of a molecular compound. Molecular compound, we mean by that is a water, and sometimes we form a gas. So it's not always that we form a precipitate. Even in a case like this, sometimes the two products that are produced after the replacement, both of them are water soluble, so there will be no precipitate. You mix two solution and you get two solution at the same time mixed together. But most of the cases where we have, as you can see, this beaker here contains, let's say, the RS, and this is the TS, and both of them are aqueous, which means that they are soluble in water. So when this happened, the replacement, the RU in this case, like for example, lead iodide, is a water insoluble, and that's why it will form a precipitate. Okay. Anyways, that will be the topic for chapter for section 3, which we will do now. For the combustion, which is the last one, it is about reaction with oxygen. So oxygen is always there. Whenever you see oxygen, this means that we have a combustion reaction. We're specifically talking about the combustion of organic compounds or hydrocarbons. Hydrocarbons, yani carbon and hydrogen, right? So whenever you have a carbon and hydrogen, you may follow this equation. I wouldn't recommend memorizing this. All what you need to do is to remember that any hydrocarbon reacting or combusted with oxygen will produce carbon dioxide and water. Just write that skeleton equation and then balance it by counting the number of carbon atoms instead of memorizing that if it is CX and HY, then this has to be X carbon dioxide. I don't believe in that. Well, that's a very special case, which is whenever we have a shortage of oxygen. That's an exception. But we're talking about the majority of them here, which is, for example, if you consider C3H8, that is propane, plus O2 to produce carbon dioxide plus H2O. Okay. And then if you want to balance that, then you have to multiply this by 3 to make the carbons the same. We have 8 hydrogens, so that has to be multiplied by 4. Then we have 4 oxygen, and 3 times 2, that is 6. So this has to be multiplied by 5. Right? Now, here's what we are, if you want to refer to this one, yeah, see, if it is, this is X and that is Y. So for this one, it is X plus Y divided by 4. Well, in that case, it's 11 by 4. I don't think that is okay. So that's why I told you don't really follow this one, because sometimes it does not apply. All right, but this is the easiest way. Any hydrocarbon with carbon dioxide, the final or the greatest degree of oxidation is carbon dioxide and water always, and then you balance the equation. All right, so this was just a review for this section 10.2, because that will help us in the coming section, which is section 3. Section 3 is about the okay, so we have to do a new share now, which is this one. Yeah. All right. The last part of chapter 11, and by the way, this is the material that you guys are going to have for the exam, although we still have about more than 2 weeks, but we can add chapter 12, but I think for you to get some good grades, it is better not to add 12, because 12 is full of calculations and it will be difficult. Huh? What? Stoichiometry, not stoichiometry. Okay, that's why I couldn't understand. Yes, it's stoichiometric analysis. That is true. It is a combination of chapter 10 and 11 together. That's why we need the types of reaction here in order so we can write a chemical reaction. And we know the quantities, you know, those convergent factors that we learn in chapter 10, which are the from mass into moles, moles into mass, particles into moles back into that. And under STP, we have the volume or the molar volume. So these 3 convergences are the basics for the stoichiometric analysis, where you can determine how much material you need and how much material you produce in any chemical reaction. Okay, this is a special type of reaction, which is the reaction in aqueous solution, and there is a reason for that. What we are going to discuss here, first of all, we're going to describe the information that found in something called net ionic equation. So we will learn how to write a net ionic equation for any reaction. And then we will predict the formation of a precipitate. Remember that double replacement thing? We said that sometimes it does, sometimes it doesn't. So how we decide, that's what we're going to look at, the rules, solubility rules, that you can decide whether a precipitate is going to form or not. That's exactly the second objective. Now, I'm not sure if you have seen this, but if you have been into one of those caves where they have something coming from the ceiling and some other stuff that coming from the ground, there's in the area here, there's one in Lebanon, and there in Europe and the US, there are plenty of them in there because they have too much rain. I mean, that's why they call these the one which is coming from the top. They call it a stalactite. And the one that is coming from the, well, it's not growing, as a matter of fact, it is from the dripping. Some drops are being dried off in the air and make that straw coming from the ceiling. And the one which is not holding up and will drop to the ground, it will start building up. So usually they will come like that, the stalactite, a stalagmite, which is the one that is coming from the ground. But anyways, what is this about? This is about one of the ionic compound that is slightly soluble in water, or you can say water insoluble, and that is calcium carbonate. Calcium carbonate is one major component of rocks. So if you have a cave that is inside a mountain and the rain is coming in, it will dissolve that calcium carbonate partially, but when it starts dripping, it will come out of solution, then it will precipitate again. So these are actually precipitates of water that contains calcium carbonate, but will precipitate slowly to the point that it is amazing. As a matter of fact, if you want to go to one of those caves, it is really, really very nice to see that. Okay, what is the net ionic equation? That's what we need to learn about. And why we are talking about I mean, given a whole section on this type of reaction, which is in aqueous media. That's very simple because your body and the earth also is full of water, as you know. 70% of your liquids are water, 70% of the earth's surface is covered with water. So most, if not all, the reactions that is happening inside you and outside you, they are in aqueous media. So that's why they are of an importance. If you consider one of those examples, which is silver nitrate, again, silver nitrate with sodium chloride. Now, once you see these two, you understand that you're dealing with a double replacement reaction. Okay, so we have two ionic compound, AgNO3AQ, which means that it is soluble in water, and NaCl. When you mix these two solutions, you're going to get something like this. And that is the product here. This white stuff is a precipitate. If you leave it for sometimes, it will look like a cloud because it's a very fine powder. But if you leave it, then it will settle down to the bottom of this graduated cylinder over here. So what is this white stuff is coming from? We have to do the double replacement reaction. So this is the positive ion and that's a positive ion. So they get replaced. So what we produced is AgCl, and that is the one which is insoluble. Now at this time, I'm telling you that it is one insoluble, but later on you'll be able to decide after you learn the rules of the solubility. But this is the white stuff, and that is the NO3. Okay, so this is a complete reaction that between a double replacement reaction. But since these are inaqueous, you know that they will exist as positive and negative ions. So all what we need to do is to change this chemical equation into what we call a complete ionic equation by separating all the compounds that exist as ionic compound in aqueous media. So every time you see any compound with AQ next to it, that means that it exists as positive and negative ions. So this will be as Ag plus NO3 minus plus Na plus Cl minus, and that in the other side. What about this AgCl? Can we put it as Ag plus Cl minus?
No.
Can we? ليش؟ لأنه فيصل قال لا يعني. Because he said no. Because it is a precipitate. It is solid. It's not AQ. It is an S. So anything that is solid or precipitate, you cannot separate it into ions. Okay. So that will remain as it is as AgCl. Plus this one we can, of course, and that is by writing this as Na plus plus Cl NO3 minus. Okay, so what do you notice about this one? First of all, we call this one a complete ionic equation. Complete ionic equation is by converting or writing all the ionic compounds in ionic form. Okay, but after that, if you look at it, you will notice that some of the ions are in the reactants and in the product without any change. Nothing has happened to them, like, for example, the sodium and the nitrate. So since they are present in both sides, we call them spectator ions. Spectator ions, they're doing nothing to the reaction. That doesn't mean that we cannot have them in there, but as a matter of fact, how are they controlling the reaction in terms of the product? No, they are not. So we can remove them. So if we cancel the nitrate with the nitrate and sodium with the sodium, then we're going to end up with only the Ag plus Cl minus to produce AgCl. And that is what we call net ionic equation. The one that is produced after we remove all the spectator ions or the unneeded ions, if you wish. Yes, that's what we do. Anyways, I'll show you this. Yeah, this is telling you again about the equation and all that. The Na and the Cl minus, that is for sodium chloride, and the same thing applies for nitrate. Also, they exist as Ag plus and NO3 minus. I just want to take you to a complete ionic equation. What is a complete ionic equation? It is an equation that shows dissolved ionic compound as dissociated free ions. That's what means. يعني whenever you have anything that is AQ, you can write it as plus and minus ions, like Ag plus NO3 minus. This is an aqueous. It is a dissolved ionic compound. Okay. Is that something clear to you? So when you have ionic compound and you put it in water and become soluble, usually they are separated by the water molecules into two ions. The water molecules are going to come in between, and they will be as positive and negative. That's all what we did here, from going from a regular, if you wish, or a complete equation of a double replacement into a complete ionic equation. But after that, as I said, you have to look for the ions that are unchanged. The nitrate ion and the sodium ion appears unchanged. So we can remove them. And those are the one which is unchanged, or they are not directly involved in the reaction. We call them what? Spectator ions. And we can remove them. So spectator ions are the ions that are not directly involved in the formation of the precipitate. طيب لو ما كان عندنا precipitate, can we do that? No. If we don't have a precipitate, then this concept of net ionic and ionic does not work here. Is this special for a double replacement, or is it possible for single replacement as well? It is possible for single replacement, because the single replacement is an element with a compound. That compound is actually an ionic one, and it could be in aqueous solution. So we can use that. Anyways, I'll show you an example in a minute. Okay, so these are the spectator ions. What are they? The ions that appears in both sides of the equation, and they are not directly involved in the chemical reaction. That the wording is very important for you to, because you know that in typical exams or homeworks or whatever, sometimes we have, the language of the question is very important. And for those who their English is, they're still building up their vocabularies, then it is good to learn how to describe or to define something. So they are appearing on both sides, and they are not directly involved in the chemical reaction. So we cancel them, as we wrote in there. This is what's left after this, after removing the spectator ion. So if somebody asks you what is the net ionic equation, it is a complete ionic equation minus the spectator ions. Removing the spectator ions, you're going to end up with something like, which is directly involved. Now, in this case, assume that our purpose is to precipitate the AgCl. This was to prepare an AgCl from some other compound. Okay, if that is your main goal of the reaction, then this is what you need. Why I need to put nitrate, and they are there, yes, they are in there, but I don't have to describe them in the equation. And that's why we write what we call a net ionic equation by removing the spectator ion. Do we have what? Crashes? Gas? No. Gases are a different story. We're talking about ionic compound that is soluble in aqueous solution. Remember that this whole section have a title, which is reaction in aqueous solution. We're not talking about gases here. And even if gases are soluble, they're not going to separate into positive and negative ion. You know that oxygen can be dissolved in water, right? But does that mean that it will be as O minus and O plus, for example? No. So that's a different story. Repeat your question again. Unchanged. طيب. خلينا نشوف. Look at this equation. We have Ag plus. وشو صار بالAg plus هون? Did it change? Yes. It was an Ag plus. Now it is combined with the chlorine. صح? That's why we form an AgCl. But look at the nitrate. NO3 minus here. What is it on the other side? That's why we call it unchanged. All right? طيب. نرجع لتعريف spectator ions كمان مرة. You have to look at the wording. The one that appears in both sides, and that's the second part is even more important. The one which is not directly involved in the chemical reaction. What is the purpose of this whole thing? خلينا نرجع back into this equation here. يعني من هون. The idea here is to form an AgCl, to prepare an AgCl. طبعا I don't want to get you into that, but there is something called for synthesis. اسمه precipitation reactions. When you want to get something out of solution, you enforce it to get out as a precipitate. طبعا once this get as a precipitate, you can filter it out and you get the AgCl separated from the others. And we're not there yet, but we want to say that whenever we have a double replacement reaction and a precipitate is forming, we don't need to write the whole equation, but rather we write what we call net ionic equation. How we do that? First of all, we take the equation itself and we write it in a form that we call complete ionic equation. كيف نكتب complete ionic equation? By changing all the aqueous compound into plus and negative. Anything wherever you say AQ, this means that you can write it in positive and negative. Then after you have this kind of equation, which is we call complete ionic equation, all right? Then you remove the spectator ions. So what is the definition of spectator ions? Again, they are the one which is appear in both sides without getting changed, okay, or without being directly involved in the main chemical reaction, which is the formation of AgCl. So that's why we can remove them and we end up with this kind of equation. And that is the main thing. Why I need to worry about the others? This is what I want. It is the net ionic equation that shows only the ions that are involved in the formation of a precipitate. Okay, now let's see, I think we have some example. Well, in addition to that, you remember that any equation that we deal with has to be balanced. Hamshi to be balanced as a net ionic equation. If we start with a balanced equation, then you end up with a balanced net ionic equation by default. But if it is not, and that's what I prefer, always check your net ionic equation for being balanced from two sides. First of all, from the mass point of view. So you know that Ag, Cl, Cl. But not only that, but also in terms of the charge, they have to be balanced. شو يعني to be in charge balanced? What do we have here? We have a positive ion and a negative ion. So positive, one negative, the sum is zero, صح? And this is zero, neutral. So they have to be like that. I will show you some examples now where we may have positive or negative in both sides. And that is in the case of single replacement. You will see that in the coming example. Okay, yes, this is a single replacement reaction. Okay, that is lead is replacing the silver. So according to this reaction, you realize that lead is listed on top of silver in the activity series. Okay, so what will happen is that the silver, which is an element, and that is a compound, will replace the silver and produce the silver will come out as an element and a compound. This is the definition of what? Of a single replacement reaction. Ion and a compound will produce an ion and a compound. How it works? By replacing the ions, they replace each other, or the elements. Can we write this in a complete ionic equation? Yeah, let's try. So this is there anything we can do about this one? No, because that's a solid material. But this one is a AQ, so this will be as Ag plus NO3 minus. And then we go to this side. This is Ag solid, so there's nothing we can do about it. Plus, this one is AQ, so this will be Pb plus 2 NO3s, right? This is your complete ionic equation in this case. Right. Look at the spectator ions. Do we have spectator ions in this case? NO3. Okay, so NO3 is the one. When you cancel it, you don't worry about the numbers that we have 1 NO3 here and 2 NO3 there. From a concept point of view, anything that appears on both sides, you cancel it regardless of the number of moles. Okay, مش روح تقول 1 وهناك 2 بضل 1 والى اخره. No, it is cancelled. So this will go with that. طيب, is there anything else that we can do? No. So what is left is PB plus AG plus to produce AG solid. I'm sorry, this is solid plus PB2 plus. This is your net ionic equation. Is it balanced in terms of the mass? Yeah. Okay, lead, silver, silver. Is it balanced in terms of the charge? No. Why? Because we have 0 and plus 1 on this side, and we have 0 and plus 2. So we need to have it balanced in terms of the charge. That's why we need to multiply this by 2. And if you do that, you need to multiply this also by 2. So this is a balanced net ionic equation, balanced in terms the mass and the charge. And that is very important to remember. It's not only about balancing the one that is related to the number of atoms or in terms of mass only, but also in terms of the charge. Anyways, you will see it here, Yara, because all what I did is written in the slide, and whether writing notes or not. Okay, nitrate is spectator ion. This is the net ionic equation, but it is unbalanced. And in order to balance it, you have to multiply this by both sides by 2. Okay? You want to try another one? Well, that is reminding you that whenever you want to balance an equation, you balance it in both mass and charge. I need to remind you again and again. One of the mistakes that you may fall in is whenever you take choices, one of them will be balanced in terms of atoms, but not in terms of charge, and people will like it because if they are in a hurry. That's why I always say that whenever you want to solve a question, you have to take your time. Speaking of that, yesterday there was something funny. Let me ask the people who are here at least. Did you encounter any problem with the homework yesterday? Raise your hand. Don't say what is the problem. Just raise your hand if you encounter a problem. You encounter a problem, you encounter a problem, you do. You didn't have any problem, and you too, and you too, and you too. طيب. The question is how you did not. There was a wrong question. الحين ذكرت ما سألتك قبل. رفعت يدك انت؟ طيب كويس، معنا هذول الثنتين. ها؟ وثيرزداي كانت صح والجمعة صارت غلط. No. أنا I don't want to accuse somebody else. بس رجعنا where we talking about before. اللي هو getting the answers. بغض النظر واحد أعطاك الإجابات وصرختهم وجيت طالع وأخذت 10 من 10 and you're happy about that. Allah, don't defend yourself. I'm not trying to accuse anybody. I'm just saying that this is a very nice notice that I received only 2 emails from 2 students only out of 82 about that problem. I know that there are some other people like Faisal who had and you and Yara, maybe you know that there's a problem, but you decided not to ask me. That's fine. But there is a majority of others, they don't even know that there's a problem. And you have to discover that. Why? Because the answer that you're looking for is not among the answers. So how did you answer it? I mean, if you did the calculation, that was about okay, well, that's a good justification. Yes, that is true. That's why I went and fixed it. I can do that, inside the questions. And this happens, by the way, every year. Because here's the way it goes. I mean, these questions are in a form that is, you cannot see it before you put them in the Moodle. They are in a form which is, they call it the blackboard, and that is, you cannot see the question. So every time we put them in there and somebody will ask, then I fix it. Every year I do that. So when I received the email yesterday, the first email, I went and fixed it, and after that nobody asked. It is just a notice. All what I'm trying to do here is just to warn you again and again about the homeworks, that it is important. Okay, like this example that we are going through, it is important that you understand each and every one of them, because that's the way you learn. I mean, do you have doubts that in this coming exam there will be a question on this? أكيد. يعني we're having only 2 chapters, and that is made out of 6 sections, right? This is one of 6. يعني almost about 17% of the exam is about this topic. So there's no way that we can ignore something like that without having question in the exam. So it's, if you want really to get a good grade in the exam, make sure that you cover all the section and you understand all the topics. All right, so that's what I was referring to at the beginning, that it is both single and double replacement we can do that. I chose a new one. Okay, that's fine. Right, let's have another example, and this time let's read it together. This is what is different about this example here, is that what is provided is not the formulas, but the names. And that is also another challenge for you based on what you have learned in Chemistry 1, right? It says aqueous solution of iron 3 chloride. So once you hear that, what is how you're going to write the equation? If who was Na? There's no Na. So that is iron 3 chloride. What does that mean? FeCl3 and Aq first, because it says here aqueous solutions of this one plus potassium hydroxide, and that is easy. So that is KOH and Aq, and then are mixed a precipitate of iron. So he's telling you what is the precipitate that is produced. So I'm just what happens here? I'm just going to write it down here. So that is what? Iron 3 hydroxide. So that is Fe, then OH, how many? 3. And that is also a precipitate or what? So that is an S plus. No, he did not say a mix. A precipitate is formed. What is the other thing that you think it will happen? So iron is replacing potassium, so we're going to have KCl, right? And that, huh? إيش? This one was not a precipitate. He did not say. Did the question say anything about it? I mean, and in top of that, Yara, do you think something like this will be a solid in water? No, no, you should be sure. Come on, this is like sodium chloride. عمرك شفت sodium chloride is a precipitate in water? This all. But anyways, it is. We said that whenever we have a double replacement with a precipitate, then we have a solution with a solution, and one compound will be solid, the other one has to be aqueous. Okay, so that is what we have. طيب شو المطلوب هو أصلا? Writing a balanced net ionic equation. So what we need to do first is to convert this into complete ionic equation. بدل ما نقول ions, we use the right word. We need to change this equation into a complete ionic equation. شو يعني complete ionic equation? We write everything like ions. خلينا بس, these are the steps. Write a complete ionic equation, and that's what we are about to. Then we eliminate the spectator ions, which appears on both sides, are not involved in the formation of the iron hydroxide, and then balance it by both mass and charge. That's what we need to do. طيب, this is the complete ionic equation. Iron chloride is an aqueous. Originally it was FeCl3 مظبوط, فبصير Fe3 plus and Cl minus. Well, potassium hydroxide is also the same thing. This is a solid material, and we have those on this side. So which one is a spectator ion in that case? It is the chlorine and the potassium. So what is left after that is iron 3 plus the 3 hydroxides, to produce iron hydroxide. Okay, now you need to make sure that they are balanced, one iron, and then we have 3 hydroxide and 3 hydroxide. In terms of the charge, 0 and 0. So this is a balanced equation. We don't need to do anything. Okay, I'm telling you that this is a very typical question in any common exam. We say that reaction of so and so will produce the following net ionic equation, and you will have 4 or 5 choices, and you have to choose based on what you know. Okay, this is the one that we have. What is the difference between a complete ionic equation and a net ionic equation? Okay, so a complete ionic equation is the one which contains all the ions, whether the one involved or not involved. That's what we call spectator ions. Once we remove them, then we end up with, of course, you can write it with different languages, but this is, if you understand, see, that's what I keep referring to many times. If you try to memorize this answer, if we bring it in, of course, we can write it in a different sentence with the same meaning. Then you get stuck there. Oh, this is not what I know. But if you understand the concept, no matter what language or what sentence we write it with, you will be able to answer. All right, the second part, which is how to predict the formation of a precipitate, whether a precipitate is going to form or not. First of all, you do the double replacement. Then you look at the products, 2 of them, and you follow the rules that I'm going to share with you now, and you decide whether one of them is going to be a precipitate or not. Mixing solution while other are not. So some combination of solution produce precipitate, some of them they don't. Whenever there's a precipitate is forming, that will depend on the degree of solubility of the products that we have. The general rules for solubility of ionic compound is the following. Somebody might say that this is a huge thing to memorize, but if you want to cut it into or divide it into pieces, then it will become very easy. Let's take a look at the first one. It says here salts of alkali metals and ammonia, they are all soluble. The exception out of this is some lithium compound. شو يعني هالكلام؟ Every time you see a compound which is ionic compound, في positive and negative ion, مظبوط. If the positive ion is any of the group 1A metals, or if it is ammonia, like NH4 plus, then in that case, it has to be soluble. There is some exception, which is the lithium. That's anything else, it has to be soluble. This is the first part. The second part is nitrate and chlorates are all soluble too. يعني مش بس انه يكون البوزيتيف ايون هو جروب 1A او اور NH4 بلس. شو رايك تسكر التليفون؟ طرشتني في المسجات تبعتك. Okay, so either this or if we have the ionic part is nitrate يعني NO3 ولا chlorate Cl4, كل هذول بيكونوا soluble. في few exceptions. منيح انه مو قال شو الاكسبشن وهذا احسن. صح؟ طيب sulfates, yes. When they will become different? We're talking here about the salts of, there's no salt of ammonia without being ammonium. يعني like this one, NH4 Cl. Is this soluble ولا لا? That's the question. Is it possible for this compound to form a precipitate? No. Why? Because it is the salt. When you say the word the salts of, that doesn't mean, when we say ammonia, we mean ammonium, because ammonia does not form a salt except it is ammonium. Okay? طيب. Sulfates يعني ال SO4s كلهم بغض النظر عن شو موجود هون, they are soluble بس في exceptions. هذول يا بتحفظهم, you have to memorize them. Lead sulfate, silver sulfate, mercury sulfate, barium, strontium, and calcium sulfate, those are precipitates. أما the rest of them are soluble. Chloride salts, they are soluble, except silver, mercury, and lead. And we saw the lead iodide, we say the AgCl, and we're going to see another example with mercury. So these are the three exceptions for the case of the chloride. This is easier now. All the carbonates, طبعا الكربونيتس, when we say all carbonates are insoluble إلا إذا كان من الالكالي metals. يعني potassium carbonate, for example, is soluble. صح? Why? Because it is a salt of alkali metals, and that is governed by the first group. Okay, so in order for this one to become insoluble, هذا الcarbonates to become precipitate, it has to be combined with something other than ammonium or alkali metals. Like, for example, group 2, calcium carbonate or barium carbonate. Okay. Phosphates, the same thing applies. Chromates, sulfides, and hydroxides. الهيدروكسيدز زي ما شفنا الايرون hydroxide was soluble, it was precipitate, while potassium hydroxide, which is belong to the first one, is water soluble. Okay. Anyways, memorizing this will become much more easier, or understanding, if you wish, the rules will become easier as long as you practice more examples. The more examples you do, the easier will be to get that. Will a precipitate form when an aqueous solution of sodium carbonate along with barium nitrate form? طبعا, the only way to answer this is to do the reaction first, write the products, and then you decide based on the rules. What will happen is that this sodium will replace the barium. So what we will get basically is barium carbonate plus sodium nitrate. Let's start with this one. First of all, هذا is a salt of alkali metal, اللي هو sodium. That's why it is soluble. And also it has nitrate. وإحنا قلنا nitrates are all soluble. فهذا أكيد إنه soluble. This is an aqueous one. نيجي لهذا. It is part of the rule, the last rule, الكربونات. Carbonates are insoluble unless they are with the group 1A. والبarium is a group 2A. فإذن this is the one which is going to form the precipitate. Okay. This is the same question, just explaining to you what will happen. طيب. How did they show the straws? This is the same question about the stalactite and all that. The answer is, the typical answer is, as I said, that calcium carbonate, which you know that it is insoluble now, will come out of solution when the water is dripping. The water is dripping containing calcium carbonate, which is partially soluble. But when it is dripping like that, the calcium carbonate is going to come out from solution and will form that solid straws that is slowly built up. And the ones which could not hold up in there will drip in the ground and will form the stalagmite, which is growing. It looks like growing from the ground. Aqueous potassium carbonate reacts with aqueous strontium nitrate. Okay, so this is aqueous potassium carbonate. Potassium carbonate is K2CO3. Akid, this is soluble. Why? Because the potassium plus strontium, which is strontium nitrate, NO3 taken twice. Then the product that we are expecting from these two will be strontium carbonate plus the potassium nitrate. هذا أكيد soluble because of the nitrate and because of the potassium, and this is a precipitate because of the carbonate. Okay, so the answer will be, look for this, do that. This is the ionic equation, and then of the two possible combination, potassium nitrate and strontium carbonate will be insoluble, while the potassium nitrate is going to be soluble. Eliminate the spectator ion and write the net ionic equation in this case. That's completing the same question. So it will be carbonate plus strontium plus to produce strontium carbonate. The others are not involved in the reaction, and which is the nitrate and potassium will be removed. Okay. In a double replacement reaction that form a precipitate, are the spectator ion, those are the one form a precipitate, or those that stay in solution? That's the one which stay in solution. If it is the one which is forming a precipitate, it will become the ions that are involved in the reaction and has to remain. Okay? Alhamdulillah. We finished that, and chapter 11 is done. So the material for the first midterm is ready, although the midterm is going to be in the 16th. I think by today or tomorrow, we will announce to you the table of all the midterms for all the materials or topics that you're talking. And I want you to pay attention from now to the location and the timing. And مش كلهم the same time. Some of them at 6, some very limited number of them at 12, the majority at 6 p.m. And they are both in the CEDX and the auditorium. I can tell you about the chemistry. It is all of them are in the auditorium because we have a large number of students. Okay. When is the first midterm? Well, it depends on your major. شو تخصصك انت؟ ها؟ Medicine? Then I guess. Well, يعني سؤالك غريب. بدك أنا أحفظ الجدول؟ أقول لك I think the 9th of February is going to be physics, but I'm not sure if it is. Huh? Anyways, you will get the schedule وبعدين بتجاوب على السؤال لحالك. Okay? طيب, I want you to write your names, please. Can you get a scratch paper and write your names? Yara, this is your responsibility. Get a piece of paper. Writing that down. يعني خلص نغلبك كل يوم. راح يكون ايش؟ أنو اللي قال هيك؟ ترديش على اللي قال لك. No, that's not true. صرنا بندرس الكورس هذا 7 سنين. We always have it as multiple choice. We never had any questions like this. بس يمكن بخوفهم شوي. That's a different story. Okay. Any question, Doctor? In the midterm going to be MCQs? Yes. The Nora and for the others, all the exams of UPP except the math will be MCQs عشان ما نضلناش نسأل نفس السؤال كل مرة. Okay.